Welcome to Homework Lib.
So over here we're asked what is going to be the solubility of AgCl, which is going to have a solubility product constant equal to 1.6 times 10 to the minus 10 in a solution which is going to be 8.8 times 10 to the minus 2 molar in sodium chloride. That means that the concentration of the chlorine ion in solution is going to be equal to 8.8 times 10 to the minus 2. So, in this case, the reaction that we're going to consider is going to be the dissolution of the solid going into silver plus Cl minus. We're going to write down an ice table equivalent for this task. In this case, a certain amount equal to the solubility is going to dissolve, and initially we're going to have 0 silver plus and 8.8 times 10 to the minus 2 in the concentration of Cl minus. Thus, the amount of change would be equal to the solubility of the compound. So at equilibrium, the solid doesn't matter, but we're going to get solubility of silver plus and 8.8 times 10 to the minus 2 plus solubility of Cl minus. Thus, the solubility product constant, which is equal to the product of Ag plus times the product of Cl minus, would be equal to S times 8.8 times 10 to the minus 2 plus S. Over here, we could go ahead and perform an approximation, assuming that solubility will be much smaller than 8.8 times 10 to the minus 2. The result over here should be equal to our solubility product constant. Over here, we're based on the fact that the solubility product constant is in the order of 10 to the minus 10. So we expect the value for solubility to be at least on the order of 10 to the minus 5, if not to be smaller. So first we're going to solve the problem with this approximation, and then we're going to solve the full quadratic expression. So under this approximation, the value for solubility would be equal to, well, the solubility would come from the following expression. If this is true, 8.8 times 10 to the minus 2 plus S is going to be approximately 8.8 times 10 to the minus 2. Thus, 8.8 times 10 to the minus 2 times the solubility would be equal to the solubility product constant of 1.6 times 10 to the minus 10. Thus, the value for solubility would correspond to 1.6 times 10 to the minus 10 over 8.8 times 10 to the minus 2, which would give us 1.82 times 10 to the minus 9. And this would be a molar concentration. Now, with this, you can already verify that the result is among the answers provided to you and would be option C. Now let's see what happens if we don't make any approximation. The only difference is that we're going to have to solve a quadratic expression where 1.6 times 10 to the minus 10 is going to be equal to S squared plus 8.8 times 10 to the minus 2 times S. Thus, we are solving the quadratic corresponding to S squared plus 8.8 times 10 to the minus 2 times S minus 1.6 times 10 to the minus 10 equal to 0. This quadratic expression, you can solve it on your scientific calculator or employing the result that the two possible solutions would be equal to minus b plus minus square root of b squared minus 4ac over 2a, which is the general formula for a quadratic expression. And we're going to find that the two solutions are a negative value, which corresponds to minus 0.088, or a positive value, which is 1.82 times 10 to the minus 9. So in this case, as you can see, the approximation was good. The correct value for the solubility can be found either ways. Remember that the negative value of the solution can be discarded since it is going to be a non-physical solution. So over here, the correct option, as I was mentioning, is option C, which is 1.8 times 10 to the minus 9 molar concentration. And with that, it would be all. Thank you very much and have a good one.